Hello everyone, this is S.G.SanjaySuman. I'm doing a project on credit card fraud detection using machine learning from Skyfi Labs. So initially we started this project by importing the necessary libraries for this project. The important libraries that we are going to be using for this is our NumPy, Pandas, Matplotlib, .pyplot, Cbon and various sklearn libraries. We read the data from the CSV file and we display it in order to make sure that the data are all the data are loaded. We use data.describe to normalize the data, and each and every one of the data is rounded up to 2 decimal places. In turn, the data.describe returns count values, mean values, standard deviation values, 50 percentile values, and other values. Here we are able to display the attributes, which is created by using principal component analysis. These attributes are user encrypted data of any credit card transaction. Therefore, we consider these attributes as the object and the class is our target. In this function, the attribute class is equal to 0, meaning that if it is equal to 0, then the transaction is genuine. If in the fraud function, n_fraud function, if the attribute class is equal to 1, then it is a fraud transaction. We display the number of genuine transactions and number of fraud transactions. Here, by means of the library matplotlib.pyplot, we are able to plot a pie chart between genuine transaction and fraud transaction. And as you can see, the data is imbalanced. This is because genuine transaction is more than the fraud transaction. Here, in this part of the code, the y is the target variable and x is the training data set. Data.iloc, and within this is used for choosing the column except the last column, that is the class, and this is used to choose the last column. In this part of the code, we are going to choose the 10 best features by means of f classification function. After choosing the 10 best features, the mask variable will store all the indices of the k best features, and hence we are printing or displaying the best features and the bad features. We use plot fraud genuine to find how the normalized data will vary with the credit card transaction. Here in this part, we are going to split the data. Sample the data. This attribute test_size is equal to 0.2, which means that 20% of the data is randomly sampled into xtrain, xtest, x y_train, y_test. Gaussian NB is used is estimated that we are going to be using, where Gaussian NB is otherwise known as Gaussian night based algorithm. Here we are going to cross validate the data, that meaning we are going to split the data into sets. Here cross validation means that each set can be used simultaneously. For example, if we use 9 out of 10 sets, if we use 9 sets, the last one is considered to be our target, and we can shuffle at the end. This is known as cross validation. Here in this part, we are displaying the training scores of each and every estimations. As you can see from these training scores, the training score is 6th set is the highest. Here in this part of the code, we are going to display the plot confusion matrix. This is the code for the plot confusion matrix. And as you can see from both of the plot confusion matrix and from this table, we are able to conclude that the predicted value is now 99% accurate and correct. Thank you.